So here I want to use the product rule on an extreme example. So instead of just multiplying two functions together, it looks like we're multiplying 1, 2, 3 things together. So how in the world would we use a product rule whenever you can only multiply two numbers or two functions together at the same time? Well, here's what we do when we have this case where there's three or more. What I do is I just pick one function to keep by itself, one part to keep by itself. So I'm going to keep the x squared by itself. And then I'm going to treat the second part as one function, okay? And then I'm going to apply the product rule. So I have the first times the derivative of the second plus the second times the derivative of the first. So let's walk through it. So f prime. So how are we going to do this? So the first is x squared times the derivative of the second. So I'm going to write out the derivative of the second. What's the second function? Cosine x ln x. Okay? Plus the second, well, what did we say was the second function? We said the second function was cosine x ln x times the derivative of the first. The derivative of first is x squared. Okay? So I have this in different color here because there's a reason for it. And the reason is this, because whenever I take the derivative of this second piece here, guess what? It's another product rule. It's the product of the first times the derivative of the second plus the second times the derivative of the first. So it's like you've got a product rule inside of a product rule. Oh my gosh, that is insane, right? A product rule in a product rule. That's exactly what's going on here. That's what you call crazy. Okay, so I need to do the first times the derivative of the second. What's the derivative of ln x? It's actually equal to 1 over x. You're supposed to memorize that. Plus the second is ln x, times the derivative of the first. Another one you're supposed to memorize is the derivative of cosine, which is negative sine. Okay? So that's the derivative of this green thingy right here. Now, I have plus the second times the derivative of the first. Well, this one's derivative is not too bad. That's just 2x. So now I need to do some simplification. I'm going to distribute the x squared in here. And so I have cosine x. But if I have x squared times 1 over x, one of the x's cancel and I'm just left with x. And then if I have x squared times ln x times negative sine x, well, two positives and a negative make a negative. And then I have x squared, then I have sine x, and then I have ln x, okay? I like to write my log ones last because if I start doing this stuff, I start asking myself, well, is this in the argument or whatever, right? But if I put this part of it before the log, then I don't have any questions. Now the next part here is literally just rewriting. I switched around the order again. Just like I said, I don't want to write those together because I might think that they're the same thing. So I'm just going to take that to the front of the line. And that's what's going on there, okay? And so is there anything in common that I can combine? No, that's it? Okay. There's nothing that all three of them had that I can... Well, I guess you could technically factor an x out of those, but I'm just going to leave it where it's at. I'm not, feeling crazy, but technically you could do cosine x minus x sine x ln x plus 2 cosine x ln x. But we don't really have to do that. We don't have any extreme advantage to doing that. Okay, so we got our answer, and that's what we're looking for. Let's do one more interesting scenario here. This is the derivative of a product and then minus another function, okay? So what I'm going to do is I'm going to handle this product first, and then I'm going to take the derivative of that other one, okay? So the derivative of the product is the first times the derivative of the second. Derivative of the second is 1 over x. And then plus the second, which is ln x, times the derivative of the first. Derivative of x is just 1. And now I'm going to take the derivative of negative x and I'm going to get negative 1 there. If I multiply this out, x times 1 over x is 1. And then multiply this, I just get ln x, and then subtract 1. 1 and 1 cancel, and so my answer here is the natural log of x. How interesting it is that the derivative of x ln x minus x is equal to the natural log of x. This will become more important towards the end of the semester when we start talking about integration. All right, guys, so that kind of ends, those little oddball ones. So see you in another video.